Good evening, Earth Science students. Tonight's lesson is going to be to characterize features produced by wind and ocean waves. Alright, so do now, make sure your notebook is open, copy the teaching point and the table of contents. Next, the teaching point in your notes, and 3, the notes that are in yellow font. I just wanted to advise that this lesson will include a lot of notes. It's on wind and ocean waves. And wind and oceans are very different. However, waves are produced by wind, so it's a good correlation between the two. Alright, wind erosion and deposition. Wind erosion and deposition depends on the following characteristics. Okay, first one, the size of the sediment being carried. Next one, the speed at which the wind is blowing. And 3, the time that the wind continues to blow. So, long-lasting storms with respect to the time, like hurricanes, nor'easters, right? That's a continual velocity for a long period of time. Speed, sometimes it can get up to 100 plus miles per hour with hurricanes. Otherwise, usually winds are somewhere between, it could be calm, could be anywhere between 1 to maybe 10 to 15 miles per hour. Next one is the size of the sediments being carried. Alright, so the features produced by wind. Mushroom-shaped rock. Lower portions of exposed rock become eroded because sand, silt, and clay, those size sediments, are lifted 1 meter into the air. Alright, so wind can only carry sediments so high, and wind can only carry very small, lighter sediments. Notice here that almost like a neck, this has all been eroded away, almost like sandblasted, and the top remains. 2. Ventifacts. Wind-blown sand may sculpture pebbles, cobbles, or boulders. Notice that we have prevailing wind going from left to right, and notice that over the course of time, the left side of this coarse sediment is getting abraded, like physically weathered by sandblasting. 3. Deflation. Wind picks up and carries away loose, fine sediments, resulting in desert pavement. So over the course of time, the desert can decrease in elevation, going from 1 to 2 to 3. And then what happens is, over the course of time, wind cannot carry coarser sediments, so they stay behind. And eventually this can produce desert pavement, which is very coarse sediments. Okay, 4. Dune migration. Caused when the prevailing winds continue to move sand from the windward side of a dune to its leeward side. Notice that it goes from left to right. All these sand grains will move up this mound, this dune, and it gets to a certain point in elevation, and it just falls over the other side. So dunes can move, they can migrate. Alright, so we have a windward side of the dune, which is very gentle, and a leeward side of the dune, which is very steep. And you have 2 notes on that. Windward side, gentle gradient and longer than the leeward side. And the leeward, also known as the slip face side, steeper gradient and shorter than the windward side. Alright, let's go into waves. Alright, waves, the up and down motion of water in an ocean or lake, usually caused by wind. So these are all incoming waves coming in into the shoreline. Right, it's the up and down motion of water. Alright, next. Alright, a crest is the highest point of a wave, which we mentioned a while back when we did our lessons with the STEM project. And for my 8th graders, this is new. A trough is the lowest point of a wave. Alright, the next one, the horizontal crest to crest, or the trough to trough distance is called the wavelength. All particles in a wave, they move in circular motions, and the vertical distance between the crest and the trough is the wave height. And your wave height can depend on many factors. The wave heights can be very small on the North Shore. They could be a little bit bigger on the South Shore, even bigger on the West Coast. Alright, so waves typically strike the shoreline at an angle. Most of the erosion energy is focused on the parts of the coast that extend into the water, almost like sandbars. Waves drag along the bottom near the shore, and as a result become unstable as breaking waves or surf. This leads to the creation of longshore currents.
When we're here at the ocean, we have waves. Now the waves on the eastern coastline are very weak, called spillers. Alright, so we have this thing called beach erosion. Waves come in at an angle. That's flush. And they return straight and backwash. Waves come in as slush, returns as backwash. Woo! Slush, backwash. Slush, backwash. And eventually, what happens is you have a direction of sand travel. Because of this swash and backwash, all the sand sediments are being moved in that direction. And after a certain time,
Alright, so that's the longshore currents. I took that at the beach in the summer. Sometimes we can actually intrude on this longshore current by building rock groins, right? So we have at least 2 sets of rock groins which are perpendicular to the shoreline. And that can really mess up the whole longshore current. Alright, longshore current, the movement of sand parallel to the shore as waves strike the shoreline at an angle. Water near the shore is usually pushed in one direction along the shore, a zigzag pattern. It's going to carry large amounts of sediment parallel to the shore. Alright, in this diagram here, notice that the arrows, they come in at an angle, and they'll go back out straight. Right, in at an angle, and goes back straight. In the video, I mentioned a word. Alright, so the word coming in is called swash, S-W-A-S-H, and when it goes back, right, it's backwash. So swash and backwash. Alright, same idea, right? Swash and backwash. And this would produce a zigzag pattern. And then notice that the longshore current is going from left to right in this diagram. Alright, jetties and groins. They're usually built to protect buildings. If buildings are built right by the shoreline. Really expensive houses are usually near the shoreline. Sometimes they're built to redirect rivers and streams or to shelter boats in calm water. And this unintentionally has ruined wildlife habitat, destroyed surfing waves, and caused beaches to erode further. All right, in this diagram, we have a jetty that was built, most likely to include a bay for ships and boats to come in and out. And notice, right, we have the drift going from left to right. As the waves slow down, we have deposition on one side, and then on the other side it begins to erode again. And this could build up to the point where this whole opening would close again. So they have ships will go out there and pump out all that sand so that this jetty, this bay, stays open. Alright, last few terms. For ocean deposition, we have sandbars, which are ridges of sand parallel to the shoreline, and those are usually underwater. Barrier islands are sandbars that reach above sea level. Alright, so people can actually have fun, go to the beach on barrier islands. And most of the islands on the south shore of Long Island are barrier islands, like Long Beach, Robert Moses State Park, Fire Island, all right, and so on. All right, and the last term here I have is a lagoon, a body of water separating the barrier island from the mainland. All right, so if you notice here, we have the barrier islands, we have a lagoon, right? So these islands here would separate that from the mainland. Alright, some practice questions. Number 17 in this case. The photograph below shows a sand dune that formed in a coastal area. This sand dune was most likely formed by... Alright, we can eliminate two choices. We know that sand dunes are made by wind. It's not made by water. So we can eliminate 1 and 2. And we know we have a steep side and we have a gentle side. The gentle side is the windward side. So the wind will come here, push the sand grains up, and eventually it would fall over on the leeward side. So the correct answer here would be wind blowing from the right side to the left. Alright, so it'd be choice 4. Wind blowing from the right. Alright, last question. Deals with oceans. The map below shows Rockaway Peninsula as part of Long Island South Shore. and that's a barrier island, and the location of several stone barriers, A, B, C, and D, that were built to trap sand being transported along the coast by wave action. Now, these barriers are called groins. Question says, on which map do the arrows best show the direction of wave movement that created the beaches in this area? We have a north arrow, right? So if you notice all these rock groins, the eastern side of each of these rock groins has beach, deposition of the sand. We got to know what direction it went. So we know that waves have to come in at an angle, and usually they come in at the same angle. So we can eliminate 2, because in choice 2, the wave crests are all coming in straight. We can eliminate 4, because they're coming in at all different angles. Alright, it's either going to be 1 or 3. Alright, so choice 1 shows the waves coming in, right? So we have swash and backwash, right? Swash at an angle and backwash. Swash and backwash. So if you notice, right, these arrows are pointing to the eastern side of the groin. Alright, which is good. In choice 3, the arrows are pointing to the western side of the groin, which is no beach sand there. So the best answer for this question would be choice number 1. Alright, so the waves would have to come in and would usually point in the direction of where you have your beach deposition, your sand deposition. Alright guys, that will conclude this flip lesson. And again, I hope it was informative about wind and ocean waves. In class tomorrow, you will have a whole bunch of questions pertaining to wind and oceans. Have a nice night. Thank you again.